We're now going to look at roots that are higher than square roots, so higher order meaning third roots and above. For the most part, I try and limit what you guys do on Cengage to third roots, but I do want to explore what happens when we take it to a larger number than 3. So in general, there are calculators that have this cube root symbol, but it's not particularly easy to find. You usually have to go through a menu, and honestly, it's a very specific button. So instead of learning how to do a third root, I'm going to teach you how to do it for any root that's over the second root. Really what we're going to end up doing is taking what's under the root, in this case 64, putting it in parentheses. Then we're going to use this little arrow up button. That arrow up button means to the power of. We've used it in the past on some things, when we took something like the third power, for instance. But if you have my calculator or one like it, it's right there, the little caret under the clear button. Again, hopefully by Google you can find take to the power of. It might look like something like y to the x on your calculator, but you want to try these, see if you're getting the right answer. If you get the right answer, you found the right button. So basically, to take something to the third root is really taking it to the 1 over that number power. So what I want to do when I take the third root of 64 is write 64 in parentheses to the power of new parentheses 1 divided by 3 end parentheses. When I put that in my calculator, it's going to tell me the answer is 4. Same idea here. Notice that I can put a negative number inside a cube root. Basically, if you think about it like looking at 1. If I do -1 times -1, I get a +1. So if it's a square root where 2 things are happening, it's impossible for my answer to be negative. Whether it was -1 times itself, which would give me a +1, or +1 times itself, it would also give me a +1. There's no way that I could have multiplied something by itself to get a -1. As opposed to if I think about 3 of them coming together. -1 times -1 times -1. This would give me +1 times another -1 gives me -1. So it is possible to get a negative answer under a cube root. Your calculator won't tell you error, it'll give you a correct answer. That said, if we went to 4th root, couldn't do a negative. 5th root we could, so on back and forth. If it's an even numbered root, you can't have a negative underneath it. If it's an odd numbered root, you can. So I'm putting in parentheses -8,000 to the power of 1 divided by 3. When I put that in my calculator, -8,000 to the power of 1 divided by 3, it tells me the answer is -20. Finally, I'm going to find in this first row the cube root of 216. 216 to the power of 1 divided by 3. When I put that in, my calculator tells me 6. This next section, we're going to be finding different numbered roots. Here it specifically says round to the nearest hundredth. Hundredth is another way of saying 2 decimal places. So I put in my first one, parentheses, 10, end parentheses, to the power of parentheses, 1 divided by 3, end parentheses, and I get an answer of 2.154. Again, we're rounding to 2 decimal places here, so this is the 3rd decimal place. Since it's lower than 5, I can just keep my answer as 2.15. When I go to do number 5, this is a 4th root, changes things ever so slightly. I'm going to put in 10 to the power of 1 divided by, now instead of a 3, 1 divided by 4. When I put that in my calculator, I get an answer of 1.778. Because I'm dropping something 5 or larger, I round up. So my final answer is 1.78. For number 6, this negative is on the outside. So when I put in my calculator, I want to put negative first, then what's inside the root symbol, 0.005, end parentheses to the power of 1 divided by 3. So negative parentheses 0.005, end parentheses to the power of parentheses 1 divided by 3, end parentheses. This tells me I get an answer of negative 0.1709. The 0 is what I'm getting rid of, so it's just negative 0.17. For number 7, it's a fifth root, so I'm going to put in negative 25 to the power of 1 divided by 5. When I put that in my calculator, negative 25 to the power of 1 divided by 5, I get an answer of negative 1.903, which just becomes negative 1.90. When I go to put number 8 into my calculator, negative 25 to the power of 1/6, it gives me an error. It gives me an error because of what I talked about up here. Here I'm taking a negative number under the root sign, and it's an even numbered root. This isn't possible. If there's an even number of negatives, they would turn into a positive. For that reason, when I put this in, my calculator says error, non-real answer. Your calculator might just say error or undefined. What I'd like you to say here is does not exist. That said, when I go to do it for the 7th root, I'm back to an odd number. So negative 25 to the power of 1 divided by 7 will exist. Specifically, when I put it in, my calculator tells me the answer is negative 1.583, which can just be negative 1.58 when rounded to the nearest hundredth.